This is Ed Robinson, Kensington College, continuing our session of C#, Chapter 6. We're talking about arrays. How would we actually pass an array to a function? We can start off by declaring and defining our two-dimensional array as before, and then we will make a function to which we want to pass the array. It's a static function, meaning we're not using an object to use it, using the dot up. It's a standalone function. We're passing. Now, how do we actually pass the array to the function? We declare our variable age. We should really call this something else, like ag, for example, being a different variable, but we'll leave that for the moment. And we're passing of that particular type, in other words, a two-dimensional array. Now, to actually pass the array to the function, then we can use something like this, where now that might seem a little unusual. Why not use square brackets or something? Well, age, you might recall, is a reference to the array. So what you're doing is effectively passing, you're telling the function where the array is. So you're effectively passing an address to this variable here to say where the array can be found, and then the function itself can then print out the element 0, 0, for example, which is, as you recall, is the very first element. So if we build and run, you should find that we print out the very first element, which is 1, which is being printed out within the function. So that's how we pass an array. You need to remember that you're just passing the reference to the array to the function, and you need to qualify what type of variable, which is a reference variable, which is receiving the array. As an exercise, you might like to try and work out how to pass two matrices to the add function, or a matrix add function, we'll call it. We've already made the matrices previously, we've added them together. Now you might try and work out how to do that within a function. You could also make an initialize function, which will accept matrix as an argument and initialize the values, passing the values to be initialized to the function. You could also make a print function as well to print the matrix out, the given matrix out. As well, you might like to try and return a matrix from a function as well, and then subsequently print it out. Let's now try now some functions, some C# functions which operate on arrays. Quite conveniently, we can have, for example, the sort function. Well, applied to our array age. Then you might like to try and print them out before and after. I'll put an extra line in there, and this will should just print them out in sequence, so you can see that the elements before the sort are as 715, etc., and after the sort you can see that they are indeed in ascending order. We could try reversing the elements in the array, and then we could print that out to see that indeed they are in the reverse order to originally. We just stop our program and try to find the length of the array. And indeed we should find that there are 5 elements in the array. We could find the rank of the array, which roughly speaking is the number of dimensions. We only have one dimension here. It's not always the number of dimensions, but it's good enough for us. So if we run that, you should find that the number of dimensions of the array is indeed 1. Also useful is to find the upper bound of the array. So if you run that, we'll find that the upper bound is 4. Well, we're saying 0 because it's the 0th. Well, it's actually the first dimension, and then in this case the array only has one dimension, so this is why we get 4 is the upper bound. If we did have a two-dimensional array, then we would use 1 would indicate, I need to stop that first, could indicate 1 would indicate the second dimension. So if you had the previous array, which is a 2 by 4 array, then this would give the value of the second dimension. So indeed, if we had a two-dimensional array, so for a two-dimensional array, the get upper bound 1 is the upper bound of the second dimension, so that in this case we've got an array which is a 2-row and 4-column, so it's 2 rows. Then when we run this, we find that we get the results of 1 and 3. So whereas we say it's a 2 by 4 array, that is to say we've got 2 rows of 4 elements within each row. The upper bounds are 1 less than that, so it's 1, even though it's 2-dimension, it's 1 and 3. How does this work in practice if you want to use this? Let's return to our one-dimensional array. So if we wanted to loop through the elements, you might recall this returned the value of 1. So if we want to loop through the elements, then we could do that using the for loop, iterating through from I less than 4. So it's 0, 1, 2, 3. So that needs to be equal to 4. So it's 0, 1, 2, 3, 4. There are 5 elements. Well, let's just see if that works okay and prints out all of the elements, which indeed it does. So once again, it's 0, 1, 2, 3, 4, not element 5. Well, we could actually generalize that by, instead of the 4, we could replace that with get upper bound 0, which of course, remember, is the first dimension, but that has the value of 4. And if we were to run that, it would give exactly the same result. But the advantage is that if we were to increase our array, then run the program, then we find that automatically that extra element has been printed out. So you can see that this future-proofs it, if you like, so you don't need to worry about that anymore if you make additions to the array. You copy one array to another. So let's first of all set up another array, which we'll call age 1. We'll better make it the same size. And then we'll write some code to copy the array from one to the other. So this notation means that this array will be copied to this array starting at element 0. So we could actually try printing out the new array. I'll change that to array 1. And now if I were to run this, I should find that my array is identical. So this is array 1, which has been copied using this copy notation, copy to. So it copies from this array to this array. We've previously talked about structures. What we'd like to do now is to make an array of structures, something like this. So let's declare a structure in our code. And then I want to create an array of structures, which I can do like this. So we have an array of structures. We have 2 structures within our array. So the array with name P contains structures of type part that contains 2 structures of type part. So we can initialize some elements. So P0 is our first structure. It's given the elements values of INS of 1 and A. We could also make another structure. So this is the second element in the array, and we might just as well access the elements to print them out. So you could print out the S element as well. You could print out the second structure if you wished as well. If I run that, I should find that the elements are given for the first structure, which are 1 and A. As an exercise you might like to try, we want to make an array of 3 structures of type stock, which hold a company name and a share price. So you might start with something like this, which is an array of 3 structures. So you might declare your structure first of all to hold a name and a price. And then we might declare an array of 3 such structures. We then might try to initialize each of these. So our first structure could look something like this, and so on. We could initialize 2 other structures. So we could print those out. It might be an interesting exercise to try and add up the prices, the stock prices, and maybe even find an average. Well, we could first of all make a variable which would hold the running total. And then we might like to total them using a running sum using a for loop. You see that we're adding the prices to the running to give us a running total. So all that remains is really to add them up, to print out the total and maybe find the mean by dividing by. That's being a bit clever there. We've actually found the length of the array and converted it to a double if it's an integer, and we're dividing by, in fact it's just going to be 3. So you divide the total sum by 3, and then we need to write out the value. Let's see if that gives us a result. So when we run that, we find that the mean indeed is given here as 1.28. As well as considering an array of stock objects, we might consider an array of class objects. So let's start off by declaring our class, and we wish to make objects based upon that class and put them into an array. So as before, we could define an array of these objects, much the same as what we did before, where these are objects of type part, and there are 3 of them. We could then initialize them, much the same as we did for our structure. And finally, we could just write them out to the console. Maybe we could write out the no, we'll just write out the value of I, since that's all we've got as data in our class, so that if we run that, it should just print out the first element. You might like to print out the rest. It's simply just printing out the first element of the array, which was the 12. Finally, we could talk about jagged arrays. Now, a jagged array is an array of arrays, and each of the arrays can be of different size. So the notation for the jagged array is a little bit tricky. Notice the idea here that you've got 2 brackets here. Remember, we had one before with a comma in between, but when we have different arrays, we've got 2 arrays here, and you'll notice that these arrays are of different length. So note the unusual way that we print them out as well, in that unusual in that there's a double pair of brackets there, which is different from when we had just a 2-dimensional array. Then we had a comma in between here, which is different. So you need to get used to that different notation. Let's see, we're missing the closing brace here. So if we were to just run that, we should find that it prints out just the first element, which indeed it does, which is the 1, which is the element. So that's how we deal with arrays which are of different size.